our degree for number 1? What's the highest exponent for number 1? 3. Does everybody see that? That 3 is our highest exponent. So our degree is 3. Is 3 an odd number or even number? Odd. So our degree is odd, which tells me right there that I have opposite arrows. Okay. So we're going to actually just sketch it. We're not going to describe the end behavior using notation today. Okay, so the number in front of x to the third is a positive 1. Everything else has nothing to do with the end behavior. You're only looking at the leading term. The leading term determines what it's going to do in the end. So because it's odd and positive, that means that the right side is going to go up because this is positive. This tells you what the right side does. The left side is going to do the opposite. And the opposite of going up would be to go down. So that's good enough. We'll just put our arrows where they should go. For number 2, the highest exponent is 2. So this is even. And it's also negative. So we can actually cross this out. This part doesn't matter. So because it's negative, that means the right side goes down. And for even degrees, they do the same thing, which means the left side is going to go down also. All right, any questions? All right, take out your note packet and let's go to page 6, and we're going to talk about zeros. Now, we've already talked about this, so this should be kind of a review because we've talked about this before. So page 6. So zeros, the definition of a zero is the value of x when the function equals 0. So for example 5, it says, use the graph to state the number of real zeros. How many times does this graph cross through the x-axis? It crosses through at here, here. Let me go ahead and zoom in a little bit. It crosses here, it crosses here, and it crosses here. Oh wait, you can't see me zooming in. Hold on. All right, what do you think those 3 numbers are? The first place it crosses would be at -2. The second place is at 1. And the third place would be at 4. So let's go ahead and write those numbers. So it says the graph crosses the x-axis at -2, 1, and 4. So there are 3 real zeros. There's 3 of them because I put 3 red dots on the graph. So now you're going to make 3 parentheses and put an X in front of each one. And remember, whenever you go to the parentheses, the sign flips. So do you see how this says a -2? So that means in the first parentheses, I'm going to put the opposite, which would be a +2. The second one is a +1. So I'm going to do the opposite, which would be a -1. And the third 0 is at +4. And the opposite would be at -4. The main thing to keep in mind is that when you go to the parentheses, you have to flip the sign. You have to flip sign. That's important. And we did this before in chapter, in our first module when we had to write that. So today we're just practicing writing our equations from a graph. Now the other thing to keep in mind is on the right side, do you see how this graph is going up? Because it's going up, I have to start with a positive number. So I don't need to put anything there. For right now, it would be a positive 1. All right, let's look at the next one. How many times does this graph cross through the x-axis? 4. So we have here, 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 and here. So that would be, and this one is a fraction, because this would be negative 0.5, because it's halfway between -1 and 0. So our 4 solutions would be at, we have 4 solutions, and it's at x equals -1, negative 0.5, positive 1, and positive 2. So you have to make 4 parentheses now, because there's 4 zeros. X goes in the front of each one. And then flip the sign. So instead of a -1 in the first one, I'm going to put a positive 1. Instead of a negative 0.5, I'm going to put a positive 0.5. And then instead of a positive 1, I have a negative 1. And instead of a positive 2, I have a negative 2. Now again, this has a positive leading coefficient because the right arrow is going up. So I don't need to put anything in front of that first parentheses. All right, let's keep practicing. Now, anytime, looking at this graph, anytime it bounces off the x-axis, that means it's a double root, okay? So let's go ahead and sketch this graph. We have a graph that has 2 real zeros. So we're going to put a point at -4 and 3. So on the x-axis, let's put a point at -4 and a point at positive 3. Now it also says it has a positive leading coefficient. So that means that this side is going to go up. Oh, I'm sorry. It has 2 real zeros at -4 and 3 and a double 0 at 1. So let's go ahead and put a point at 1 too. So it has 2 real zeros, one at -4, one at positive 3. It also has a double 0 at 1. Okay, so that means that this is a 4th degree and both arrows have to go up because we have 1, this is 1, this is 2, and this is a double. So that would be 3, 4. So if it's even and positive, that means both sides go up. And so you're going to come through, and then it has to bounce off the bottom and then come back through the top. So we only have 3 parentheses. So for the first one, I'm going to put a +4. The second one, a -3. And the third one, a -1. Except that -1 is squared because it's a double root. All right, let's look at this next one, page 7. So we got 3 more to go. So for page 7, it says the first thing we need to do is describe our end behavior. So this, anytime it says negative infinity, that's the left arrow. Positive infinity is the right arrow. So if you look here, notice on the left side is going down, so that means negative infinity would go here. And the right arrow is going up, so that would be a positive. So relative minimum, we don't have a minimum or a maximum because it's odd degrees. But we do have a relative minimum where you see a frown, so that would be right here. That's my relative min. So right here is my relative min. Let me go ahead and label that. That's the relative min, and that looks like it's about 0.5, 0.5. So I'm going to approximate that as 0.5 and negative 0.5. So that would be my relative min. And then at the top of the hill right here, that's a relative max because that's a hilltop. That's at -2, +6. So how many real zeros do we have? How many times does this graph go through the x-axis? Let me zoom in. It crosses here, here, and here. So it crosses at -3, 0, and 1. So it has 3, and the zeros are going to be at -3, 0, and +1. So your x-intercepts would be at -3, 0, 0, 0, and 1, 0. And your y-intercept is also at 0, 0. Now, all odd degree functions have the same domain and range. And that would be all real numbers. So if it's an odd degree function, it has opposite arrows. Your domain and range, that looks like a O, let me fix that. It's all degree functions. All odd degree have the same domain and range. All right, so let's go ahead and write our factor form. So we have 3 degrees, 3 zeros. So we're gonna put 3 parentheses. X goes in the front. So in the first one, we have a +3. 0 is the only number that doesn't have a sign. So you could put a +0 or a -0, or you could just leave the X by itself. So 0 is the only number that does not have a sign. I'm gonna leave the X by itself. But you can either leave the X by itself in this parentheses, or you could put a +0, or you could put a -0. And then here, what am I gonna put? Because I have a +1, what am I gonna put here? A -1. All right. Let's do this one here. So I'm gonna actually skip over this part because we've already did one like that. Now I do want to do our end behavior though. Both arrows are going up, so both sides are going to approach positive infinity. How many real zeros? How many times does this graph go through the x-axis? 4. So it has 4 zeros. So now we got to list where they are. All right, so where are they? Looks like we got one at -5, -3, positive 3, and positive 5. So we have 4 zeros at negative 3, negative 5, positive 3, and positive 5. So we're going to write them as ordered pairs. Now my y-intercept, that's up here somewhere. I don't know what that number is. We'll just say it's above 200, maybe. So it looks like we're counting by 40s. So we'll say that's halfway. So let's say that that's about 220. So my y-intercept is at 0, 220. We're just approximating that. Let's not worry about the range or domain. We only have to do that for an odd degree function, and this is even. How do I know this is even?
Both of the arrows are the same.
Yeah, arrows are the same. So let's go ahead and make our 4 parentheses. And we have a plus 3, a plus 5, then a minus 3, and a minus 5. Okay, our last one. So is this function even or odd? Let's go ahead and add our arrows. So the arrows are going opposite, so this is an odd degree. Now, because this side is going down, does everyone see how this side goes down? That means that this is a negative function, not positive. So this 0, it has 3. The function has 1, 2 real zeros. It has 2. And the zeros occur at what? This is so blurry. So I'm pretty sure that's a negative 2. And that's a positive 3. So we have 2 zeros at negative 2 and positive 3. One of these is a double root, though. Which one do you think is a double root? The negative 2 or the 3? The 3, because see how it bounces off the bottom? It doesn't go through at 3. It bounces off. So the 0 at 3 is a double. So we only need to make 2 parentheses. Put the X. And then flip your sign. So instead of a negative 2, you're going to put a plus 2. And instead of a positive 3, you're going to put a minus 3. But because this is a double root, we have to put that square on this factor. One more thing we have to do. Only because this is a negative leading coefficient, we do have to put a negative 1 in the front. You only have to do that when it's a negative leading coefficient. So if the right arrow goes down, we have to start by putting a negative 1 in the front. Only when it's a negative leading coefficient. All right, so tomorrow homework 1 is due for module 2. Go ahead and use this time to finish it out. If you finish it early, you can turn it into the blue tray in the front. And it's not, I'm sorry, it's not due tomorrow. I am so sorry. The 18th is Wednesday. Today's the 16th, right? Yeah, so the 18th is on Wednesday. So let me fix that. The 18th is Wednesday. So your homework is due Wednesday the 18th. So you got a couple more